Okay, in this video, I will show how the neural network solve the exclusive OR problem. So, by solving the exclusive OR problem, we need to know what is exclusive OR actually. Um, when the x1 and x2 is stands for the input data, the y is stands for the output. So when the input and the both of the input data is same, the output will get 0, while when the both of the input data is different, so when x1 is 0 and x2 is 1, so the output will get 1. So as you can see, this graph plotting show that the blue dot actually is 0, represented by the when the x1 and x2 is 0, so we get 0, and the green dot is represent for the 0 and 1, and you get 1. So this is the example of plot diagram showing the neural network. Actually, the hidden layer actually is the learning algorithm for the neural network to predict the output by predict the to solve the exclusive OR problem. Now let's start by we have to implement the hidden layer and learning algorithm for the neural network, and in this part we need to define the forward path for our network, which we need to initialize the weight, and next we need to to define the loss function, because loss function is actually a cost function and mean square error to measure how good or bad for our output of the network. And next we can go to the backbone of the neural network training, which is in here we are using the backpropagation. So the step of the backpropagation actually is to compute the predicted output using sigmoid function, and we compute the loss using the cost function, which is loss function, and then we need to calculate the new weight and new bias until we can minimize the error. Okay, next in here it show the backpropagation coding. Well, all the calculation equation they transfer into the code. So as you can see, there are many versions of the propagation code. As you can see here, the function, the first one is the backward, and then is simplify and become shorter and become the faster, and the latest version of the propagation code is become shorter and show as defined as the function f backward pass. Okay, next we can start to train the network from epoch 0 to 10,000 epoch. So as you can see the output across the time, the cost function is getting smaller, so which means the training error will become smaller across the time. In the training process, actually from the first step we need to make prediction, and then we need to find the error. After that we need to find out the error and correct it to find the new weight by which the new weight tool actually is able to find by the old weight tool and minus by the error to find out the new weight and update it. In show the output for the train network show that while the epoch is trained across the time, the training error becomes smaller. So which means the training is go through the regularization to avoid the overfitting. So the regularization is used to avoid the overfitting for the data. Okay, after we get the latest neural network weight from the previous section, now we can test it with the input data. So given by the 0, 0, 0, 1, and 1, 1 is predicted as 0. So as shown in this output plot, the 1, 1 is equal to 0. So it shows the output as same as a exclusive OR function too. So that means the train network is trained very pretty well due to the output. That we can plot out the decision boundary for the network. For the decision boundary, the green dot is whatever inside the plot is defined as 1, and the blue dot in the decision boundary is defined as 0. The question is how the learning algorithm manage the noisy data. So in here, after we train the neural network for exclusive OR problem, we can plot up the decision boundary. That we can use the decision boundary to determine the accuracy for the neural network by compare with the noise or the output data. Okay, so there are two noise plot showing here by with two different way. In the second graph, it shows the output data in green and blue color, which green color is actually is represented by 1 and blue is represented by 0. For the third plot is actually demonstrate the output data with two color, which is red and gray, which the gray color is represented by the correct predicted output, while the red color is represent the wrong predicted output. So by comparing both plot with the decision boundary, we can know that which data is correct predicted and which data is not able to predicted by using our network. So that we by analyze the unpredicted output, we can train back our network and increase our network accuracy.